All right, here is question number 2. We want to calculate the heat of formation for the decomposition of 2 moles of water according to the following reaction. So again, calculate heat of formation. We like to box our question. We're going to separate the reactants and the products. Left-hand side is my reactants, what I start with. Right-hand side is my products. All right. So again, I'm going to use my chart to find the enthalpy of formation. So I have liquid water. So I find liquid water, so we're going to use this number. I want to point out though that this one does have a coefficient in front of it, so we're going to need to use our coefficients. So when we have a coefficient, we always multiply by the coefficient. So I am going to have 2 times the enthalpy of water from our chart. Sorry, that's my emails. They may pop up. I can't turn them off, or I don't know how. Then we're going to go over to the reactant side. Here's a key point that you need to know, though. And I'm going to need you to write it down, highlight it, do something, right? So when we have a reaction and we have just elements in here, right? That means, let's do my key point down here, right? So a key point is that elements in their natural state so just hydrogen, just oxygen, just carbon, any element off the periodic table that is not bound to anything else is in its natural state. And they have an enthalpy formation. Oops, sorry. They have an enthalpy of formation that is equal to 0. One thing I do want to point out to you is that we do have those elements that are special 7, which are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, the highlighted ones. Those are all, in order to be in their natural state, they must all have a little 2 behind it like this. If they do not, then their heat of formation will not be 0. So we're going to continue. We have a coefficient of 2. Again, I do have hydrogen in its natural form, so that means its heat of formation is 0, plus oxygen in its natural form, which means it is 0, right? We're going to go ahead. We're going to plug this into our calculator. 2 times negative 285.8, and we get negative 571.6, and that's one number. Okay. This one, I do 2 times 0. 0 times any number is just 0, plus 0, so this side is 0. And then we're going to plug it into our equation. Delta H of the reaction is equal to delta H of the products minus the reactants. So therefore, we get our products, which is 0, minus our reactants, which is negative 571.6. The delta H of the reaction is equal to positive 571.6 which means that this is positive, not negative. We had to add heat, so that is endothermic. So again, the key point here, I wrote it down, right? Don't forget this. Elements in their natural state are 0.